This is my latest version of my linear actuator based robot. I've finally found an arrangement of the actuators that I'm happy with that can keep the arm compact while also providing the full strength in the two primary directions. The base here consists mainly of two linear actuators, both connected to the arm, one directly via a direct link, the other via a belt control through to the elbow, which gives the elbow full power in the against gravity. On the base, have a direct DC motor controlled by a small motor driver, which in turn is controlled by a little Arduino, which also reads the analog input voltages from the potentiometers and the magnetic encoder. The wrist consists of three AX12 dynamixels connected relatively closely together in order to keep the radius small so that the torque is increased. The gripper consists of a small linear actuator connected directly in line with the closing mechanism. This allows it to have full power and also hold its position with no current flowing. That is controlled by an OpenCM module, which is connected via USB through to the Raspberry Pi, which is the main brains of the situation. This in turn has an LCD screen attached and a Raspberry Pi camera. You can see here the feed from the camera. Currently you can only view with it. It has no feedback mechanism, but ultimately I will try to get this robot arm working off vision rather than off a pre-programmed set of positions. Touchscreen allows me to bump the motors in the various directions. The base, it's a lot of slop in that direction because of the high gear ratio backlash, as well as flimsiness in the mechanism in general, which I need to upgrade in a future version. The main motors are powered by a hat that sits on top of the Raspberry Pi, which has two motor drivers. I did have a four motor driver version, but that burnt out pretty quickly with the load from these actuators. The actuators have a series elastic spring inside them, which provides both safety for when I accidentally drive it too far and also a means of measuring the force. You can see here on the display I measure both the position and the force of all but the base actuators. Now I'll attempt to pick up the dumbbell using the on-screen buttons. It's quite twitchy because the buttons only add or subtract positions. And close the Alright, so the spring now is at full tension, which means the gripper is fully engaged. So the robot has no problem holding that weight at that radius. It can even extend quite far out, maintaining the 2 kilo load. There's plenty of slop in the mechanism, which really needs to be addressed at some stage. And because all the actuators are linear or have a very small area of influence, if I turn the power off, the robot still holds its position even with the 2 kilo load.